What people don't really understand is that to be a master at Blender geometry nodes and at the top 1% of the 3D modelers and 3D designers that use them, you don't need to know everything there is to know. You actually only need to know a few core key concepts, and you'll reuse those a million times to create some really interesting things. And we're going to cover really all of those core key concepts in the recreation of this Mace chain lighter holder. The concepts that we're going to cover are these: node-based 3D modeling, easy to advanced methods. We're going to go through a lot of my best tips and tricks that I use every day. My most used nodes specifically, like the instance on point node, set position node, mesh boolean, as well as my most used nodes that I've made myself, my custom node groups. We're also going to go through attributes and how powerful those are. For whatever reason, I spent way too long being confused about attributes and how to use them. And I think it's because nobody really explains them very well. So I'm going to try to explain them a little bit better to you and hopefully save you months of confusion and frustration. And then we're going to cover how to use nodes really intelligently to make complicated assemblies and parenting. We're going to do this in parts. We're going to first make the spike ball. We're going to make it procedurally so it can be any kind of spike ball. Then we're going to make the chain link and then put it on a chain. And then we're going to bring in this pre-made mesh that is a lighter holder. And actually 3D prints into all of these parts and locks a big lighter holder inside of it. Like so. When we're done making each of these components, we're going to assemble them all on a chain. All right, let's make a spike ball. First thing I'm going to do is add a vertex to my scene, and it's on that vertex that I'm going to go up to my node editing window, and you can see it's set to geometry node editor. I'm just going to hit new. And I'm going to just add, to get started, an icosphere. By hitting Shift A and just typing in what I want, it'll allow me to add the search node into this scene. And when I plug it into the group output, that's what creates geometry. Now, there are a lot of videos that can show you how to, like, what are the steps by steps for creating a node tree, shortcut keys, and how to use the user interface. There are a million videos on that. I'm not going to spend much time on that because there's other videos. I'm going to try to spend and focus most of my time on what I don't think other people are teaching very well, which is really the theory and process in depth. We want an icosphere, and we actually are going to want two spheres. But before we get to that second sphere, let's pull the radius value of the sphere, which when we change it, changes the size of the icosphere. This node group is going to get pretty complicated. There's going to be a lot of nodes. So let's make a habit of pulling the values that we want to continually reference and reference easily and quickly into the modifier group. And we do that by pulling on the socket and dragging into the group input node. And now we can see it's right here. Cool. But we need two spheres to make that spike ball. One sphere is going to be the actual mesh geometry that the spikes appear to be attached to. The other one is going to be actually an underlying mesh that will be invisible, but it will be the mesh that, you know, the spikes are coming out of. And you can kind of intuitively already tell that, like so. Great drawings. So it looks like what we want, let me change the color of this, is we have these surfaces, and I think it's the center of each surface that we actually want the spike to be coming out of. So let's see how we would do that. First, we're going to do the underlying ball, and I'm going to just increase the subdivisions there. Then I'm going to click on this, Control-Shift-D to duplicate it with the input socket still tied together. I'm going to drag out from the output socket and go search for instance on points. We're going to use this node like crazy. And what the instance on points node does is it takes points as in its input and then puts an instance on each one of those points. Pretty straightforward, actually. Now, what are the points that we want to put on these, or what are the objects, the 3D meshes that we want to put on these points are spikes, or the geometric term for spike, which is a cone. Now there is a cone node, so we're going to just search cone, hit enter, and now we have a cone, and we see all the inputs. there for the size and shape of the cone. Now let's preview what this cone looks like and isolate it in my node group. Really useful thing to be constantly doing is previewing the node, and there's either you can plug the nodes that you were trying to preview into the group output node, or you can use a viewer node to preview it. So I can see that I have some very finite control of how, here let's go into solid view. Oops. Of this node, or the spike here. And that seems to be about the size and shape that we want it to be. So if we plug that into the instance on point node in the instance input socket and we preview that, let's see what, whoa, that's wrong, right? Oop, way too many subdivisions. Let's fix that. So we go to 1. Okay, better, but still wrong. Now, because we're using the icosphere into the instance on points node, it's just referencing that icosphere and then it's gone. It's just being used as a reference. So to be able to see it, which I want to see it and see what's going on here, I'm going to pull out a join geometry node and plug this into that and preview this now with the icosphere that we're referencing actually showing up and being shown with what the instance on points node is doing. Okay, so what we see it's actually doing is it's not doing what we said we wanted, which is putting a cone at the center point of each one of these faces, right? It's putting them at the points. It's doing exactly what we're asking it to do. We just didn't realize that's what we're asking it to do. So first let's fix that. And there's a really easy way to fix that now. It's called a mesh to points node. And the options that this node gives us is it says basically like, hey, do you want to reference the points of the node or the edges of the node, or the points of the mesh or the edges of the mesh or the faces or the corners? In this case, we want to actually reference the mesh face, and it'll default to going right to the center of that face. So we just add that between the icosphere and the instance on points, and already, boom. Okay, so it is going to the center now. That's good. But they're all pointed up, and that's a problem. Let's fix that. The way that we fix that is we want to reference the normal of each one of these planes. And what is the normal? The normal is the direction that each of the planes is facing. That's what normal means in 3D geometry terms. All right? How do we get that? Well, there's a useful node called align rotation to vector. Now, rotation can be very confusing. It's a complex geometric concept. The concept of orientation, rotation. Try not to get intimidated if it gets confusing at any point. It gets confusing to even the most advanced node users. And that's true. I've been in Discord chats where there's like the best node users on the planet. And I think that's really true. They're all there. And we're getting confused by rotation stuff. Don't get intimidated or freaked out by that because you don't need to understand a lot. That's kind of the point that I'm trying to make. Just do what you're told. Look up the solutions that other people have done and reuse those solutions. Use what works. And if you look long enough, you can find something that does. And some things you will be able to easily understand, other things you'll just have to know and reuse. That's just the nature of programming in general. And in this case, we're programming geometry. Just Google it. All right, but in this case, align rotation to vector. We're going to plug that into the rotation on the instance on points node. I'm going to now shrink this down so we can get more view of the node tree. Okay, so we see that it's not done anything yet, right? And what did I say what was the node that or the attribute that we wanted to reference? It was the normal, right? The normal of each surface is what we want to align these nodes to, or these cones to. In order to do that, there's actually a normal node. So let's grab that. And it's a read node. So it seems intuitive that all we would have to do is actually plug the normal into this vector. It seems like that should work, and yet it does not. Well, to understand why it does not, the viewer node, again, is a really powerful tool. So when we click on the, let's preview what the normal node is telling this geometry node tree. So to preview that, I'm going to attach it to the viewer. My shortcut is what is it? It's Control Shift left click to attach it to the node tree. And this is distracting. We don't need that anymore. What we can see is that the way that the preview node represents, and actually the data that's being used to tell the computer the direction of things, the normal value of things, is an RGB gradient, an RGB value that is being represented and shown to us here, so we can kind of get an idea of what is happening. Notice that the RGB values that we're seeing are all the same per cone. Again, this is a case where we're saying that the node tree isn't working, but it's actually working exactly as intended, because what this is showing us is that the node, the normal that is being sampled is the normal of each indice, which is just identical to the other one. So what the node tree is actually saying here, if we look at it closely, is we're telling it to align the rotation of each spike according to the normal direction of each spike. Align the spikes by the spikes is what we're saying, which of course means don't change anything. So the context of where this normal is in the graph is really important. And in this case, we want to sample the normals of the faces of this isosahedron, not the normals of each cone. So how do we do that? We're going to use a capture attribute node, and we're going to put it right here, right before this isosahedron goes from a mesh to points. And we're going to plug it in as capturing the face attribute. We're going to plug the normal into that. And now let's preview this normal. It all goes black because it's not yet relevant. It's not yet connected to the cones. But what if we look at preview? Oh, that didn't work. Oh yeah, there we go. If we preview both the icosphere, or the isosahedron in this case, and the normal, we see that each face is a completely different color. And this is exactly what we want. This is showing us that each face has a unique normal, which means each cone is going to be facing a unique direction. That's exactly what we want. So let's see what happens if we plug this now into that vector input socket. And we preview that. Boom. There we go. And now if we look at, yeah, there we go. It's coming out of each face. Successful. This is a really useful already right here. What you just learned here is really useful, and you'll use it a ton. Now let's unplug that and plug it into this. Now let's adjust our cones. Now this is super cool, little spike ball here, but it's not looking right to me. The spikes aren't in the right place. At least not where I expect them to be. And maybe this would be a cool mace. I actually think it is kind of dope in a certain way, but it's still, I can tell it's wrong. It's not in the right place. And because I've worked on this before, I'll tell you what I discovered. So what we actually want as the underlying sphere that these spikes are built onto isn't an isosahedron like this. What we want is a dual mesh. What we want is a dodecahedron. And we can get that by applying a dual mesh node to the icosphere, which changes it from an isosahedron to a dodecahedron. And we plug that into our node tree now. And boom, that's looking way better. And the reason for this, if you know your geometry, is that each of the platonic primitive solids has a dual, and the dual of an isosahedron is a dodecahedron. So that's how you get that. And we are really close to done. And for many of you here, maybe that's what you came to the video to learn and you are ready to go. However, there is something else I want to cover, and that is a little bit more about attributes and how to use them. And actually, the best way that I've learned to actually understand attributes is to use attributes that are captured and stored in the geometry node tree to manipulate actually shader editor nodes to make impact on the material. For whatever reason, when I started doing that, it started clicking for me what attributes actually are and what they're actually capable of. So let's go to the render view and let's make a material for this guy. So I'm going to make a material on the material panel, make a new material, and I just want to make a chrome material, shiny metal. So I'm not going to change the base. I'm just going to turn metallic up. I'm going to turn down roughness, and I'm going to call that chrome metal. Now notice this isn't working. It is the spike ball that we made the material for. If you're familiar with Blender, you used it before. Our mesh should be this material, but it's not, because this mesh is generated after the underlying mesh. Remember, we turned this geometry node tree off, and what the mesh actually is, it's just a single vertex. This vertex is chrome. I can promise you that. But the geometry that's generated from a geometry node tree is not chrome yet. We have to set the material. I'm going to turn off this viewer. Say chrome metal. Now it's referencing that material, and actually it's not where it's pulling this material from. It's just from the library of materials that are set in the scene. It's not actually needing to even pull materials just from this mesh itself. We can actually delete this from the mesh. It's not attached to the mesh in any way. It's just pulling from the library of data that the Blender scene has attached to it. And because we made chrome metal in this file, chrome metal is now available to us. Now let's play with some of the settings of this material. I'm going to open another panel, open the shader editor, get that chrome metal out again, and we see the simple node editing setup. See the simple material in the shader editor. I want to actually control metallic. These three actual top. Actually, yeah, I want to control base color, metallic, and roughness, all from my geometry node tree, so I don't have to keep going over to the shader editor, theoretically. Say that I know that is going to be the case, that in the course of doing all this design work, I'm going to be going back and forth, and I don't want to do that. We're going to put all of those values actually in the geometry node editor, so we don't have to keep going back and forth. All right, so I'm going to use an attribute node. I'm going to name this attribute color. Plug it into there. I'm going to make another one. Just duplicate this one. I'm going to name it metallic rough. Actually, I'm going to lowercase these. I don't know if these are case sensitive. I think they aren't. Let's test that. But just in case, simpler to remember. Okay, what we did is now the material here is looking for an attribute to input into these values. And the reason why it's all going black is because that attribute does not yet exist. And I'll show you what I mean by adding a stored name attribute node to this node tree. Now, if we click in the name input value here, it will show us some of the attributes that are actually already present in the mesh, but I don't think that's all of them. If I pull up the named attribute node, yeah, it will show us a couple more. This is a list of the attributes that already exist. They've been generated automatically in the creation of the attributes, and now, or creation of the mesh. Attributes, a good way of thinking of attributes, it's just some metadata of this mesh. And knowing what that metadata is and manipulating it will actually be a really powerful tool. There's infinite things you can do with that. And again, let's use that to actually modify the material. So notice in here, there's no color, metallic, or rough attribute yet, because those have not yet been brought into this. What we are going to be doing, by the way, this goes from geometry node to shader. So what we're trying to do, it doesn't go the other way around. We collect the attribute in the geometry nodes, and then we send that attribute down to shader nodes. Doesn't go the other way. So in this case, what we need to do is we need to create that color attribute. So let's type in color here, and it's got to be exact match. And change the data type to color. And it can be point, face, or face corner. I think it can be all of those. Now it's reading that color. So check this out. When I go like this, I can now manipulate the color inside my geometry node tree. Really useful if I want to pull it into the group input. So that is then in my modifier panel. Cool, right? And again, what I'm doing is I'm capturing this attribute, storing this attribute in the Blender library inside the geometry node tree, and then sending that attribute into the shader editor using the attribute node here, color. And if I change this, it breaks. So these names need to match. Now, let's do the same thing with metallic and rough. So I'll just recreate this, call it metallic, but make sure the spelling matches perfectly. And instead of color, I just want a float value of 0 to 1. So if I put 1, it's now fully metallic. And I can change that here. Do the same thing with roughness. Or I just said rough, right? Yep. And I had the rough set to 0. Okay, now we're going to do something that I can't believe we haven't done yet. I'm very surprised. We're going to make a custom node group. I'm going to want to make each part of this mace this chrome material, and they might need to slightly differ from each other. So that means I'm going to want to reuse these nodes in a few different places. And I want every place that I reuse that node group to be slightly different and not the same. How do we do that? Well, we create little custom node nuggets that we call node groups. And all I have to do to do that, select all of these and hit Control G. And it immediately grabs these, groups them all, and then pulls us into that node group. To get out of that, I hit Control Tab. And now I'm looking on the outside of the node group. To get in it, Tab. Out of it, Tab. Control Tab. Now I want to bring each of these values to the top of that node group. So I'm just going to plug them in. I'm going to open the end panel, and in the group tab, I'm going to rename these. So I'm going to rename these color, that metal, rough. Ooh, what did I do there? I'm going to rename this node group Chrome Metal Material. Now, this adds, not only does this create a node group, but it's a node group that's now in the search directory. So if I hit Shift A and I hit Chrome Metal Material, hit Enter, now I got a duplicate of it. And look at this, 2, 2. That number is telling me how many of those node groups are in my scene being reused in this Blender file. So if I make another one, 3. And if I want to make a slightly different node group that doesn't match these other groups, that's not a direct copy, I hit that button, and now this is its own unique one. And you can see in the name that it's now Chrome Metal Material 0.001. So it's not a direct copy. So I can make changes to this one, it will not sync to this one. But if I make changes to this one, it will sync to this one because this is a duplicate of it. Really useful. You're going to use that a ton. That itself right there is what makes geometry programming with nodes so much more powerful. If you may be already getting a sense that, like, wait, that means I don't have to redo certain things multiple times, or that means there's one place I can go to change a value that has a cascading effect on the whole scene, and that's exactly what it does. Really, really, really powerful. Okay. Anyways, are we done there? I don't want this to be pink. I don't want this to be desaturated completely. There we go. What do we have to do? What's left to do? Okay, I'm gonna. By the way, actually, another note on node groups is this itself is a node group. So I'm gonna call this spike ball. Metal spike ball. That's what I named that. And I'm gonna create another vertice. I'm gonna create another geometry node, and now I'm gonna search metal spike ball. Put that in there, and boom, I got another spike ball and each of these values that's at the top of the modifier, and you can see that too up there. But each of these values that's at the top of this node group are the values that aren't inside the node group, so they are not impacting each other. That makes sense. So if I turn on the radius here, the radius over here is not unchanged because it's above the node group. It's only the values that are inside the node group that are synced and matched here. So if for example, the cone is still inside the node group, and as I change that, boom, node groups, man, so powerful. Okay, so that's one of our node groups. So in this metal spike ball node group is almost done. There's one thing I want to do, and this is where things get a little bit semi-advanced. I want there to be a kind of a flat surface underneath each one of these, and a big flat surface on the bottom, because that needs to be flat because it's going to go against the print bed in order to be 3D printed. And what we're trying to do is make a spike ball that can be 3D printed. What I need to do there is make this dodecahedron repeat and a bit bigger. Maybe actually I don't need to. I'm just going to pull it and do a mesh boolean. Now this is one of those nodes I mentioned earlier, a node that you're going to be reusing a ton. However, I recommend you use my custom bool tool node, but I'll show you how to do it just with vanilla nodes. We're going to plug these we're going to plug everything into one socket of the mesh boolean, and the other socket is going to be the dodecahedron. That's not working. Why is it not working? Actually, that's not what we want to do at all. I'm going to pull this out. We want to attach those instances out, and we want to attach, wait, no. I'm getting it wrong. It went to the icosphere, because that's the mesh that we want to impact. So I'm going to plug that to the top one. The top mesh one is the mesh that we want impacted. And then the dual mesh, which is dodecahedron, we're going to plug that into the other one. And we're going to change this to intersect. Now, a point of caution, mesh booleans can be very heavy processes, and we can see that if we turn on the timings, so that now above here, each of the nodes is showing how much time the mesh takes to process. So the icosphere over here, because it's 6 subdivisions, that's a lot of subdivisions. It takes 54 milliseconds to generate. Good to know. Actually, it probably couldn't be 6. But yeah, mesh booleans can take a lot. So be cautious. I've crashed my computer a million times by just mesh booleaning the wrong thing. But we're going to preview that right now. And it's set to intersect. And what's happening? Nothing. It seems like it's not just a dodecahedron. But the reason for that, if we bring a join node, and actually instead of booleaning these two meshes, we just join them together, turn on the solid mode and view it through. The reason why this just looks like a dodecahedron, because the dodecahedron is entirely within the sphere, which means we are isolating the parts of the geometry that intersect, and all of it intersects, if that makes sense. So what's left is a sphere. If we change the scale, we're going to use a scale elements node to change the dodecahedron so that actually some points of the dodecahedron are outside of the sphere, we'll see that the impact changes quite a bit. So let's scale this, so that some of it's inside, some of it's outside. Now let's look at the mesh boolean. And now, yeah, we've created those flat spaces. And those flat spaces are the space correlate with the spaces that the cone comes out of. Let's see if that works. Boom. Yeah. Okay. You see how we had to kind of go back and forth between the join geometry and the mesh boolean node? And there's a lot of kind of troubleshooting there. That happens a lot. So I've made my own Dojo bool tool. And this works a little bit differently than the default mesh boolean node in that you can plug them both in and then preview them. And it's until you hit the cut button here, it's just operating like a join mesh. So you don't actually need to do all that, create all that mess to troubleshoot it. You can use one node. It does everything you need to in intersecting difference, but before you hit cut, it just joins it and previews. And then when you hit cut, it goes through. So that makes your job a lot easier. I use the Dojo bool tool. I think on my last project, I used it 67 times, probably 69 times, nice. And just saves me so much time. And if you look in it, it's not that many nodes. It's just kind of all the possibilities stored in one place. But yeah, we want to plug that in. Yay. And now when we change this value, that changes the flats. And we want one of these cones gone. So the way to do that is to make use of the selection node here. I'm going to pull this out to an equal node and plug in an index node. Okay, index node. What is index? What did I just do here? I just told the instance on points node that I only want it to reference one mesh point. And the mesh point that I want it to reference is point 0. How did I do that? Because what is an index? An index is just a list. I'm just telling this node tree to look at the list and select the item on that list that is equal to 0, which is the first item on the list. Now, if I open up a spreadsheet, this is where all the lists are. And it can actually look through and see what we're doing. So if I preview the points and I have the point domain selected here, done here, this is the list. This is the index, 0 to 11. I'm telling it, look at 0, isolate 0, and only instance cones on that point. And that's why it instanced that one. But the irony is, I don't want it to instance that one. That's the one I don't want it to instance. I want it to instance all the other ones except for that one. Well, that's easy. Instead of having this as equal, have it as do not equal. Now, preview that. Perfect, I wanted that blank. That's exactly what I wanted. Now we're done. We are done. Except actually, let's add a smooth by node, which is, or smooth by angle, which is what you need to basically make this kind of auto smooth. I'm gonna turn this down to 15 degrees and ignore sharps. And now that's looking exactly the way that I want it to. Okay, well, for the purposes of this video, we are completely done with the spike ball. And we're gonna move on to, from here, the chain and the handle. As we're assembling these things, we're gonna do a few more things to the spike ball to make